Okay. Hello, my name is Samantha Bayard, and I will be moderating today's media availability with Armel Castellan, Environment and Climate Change Canada Warning Preparedness Meteorologist, and Nathan Gillett, Environment and Climate Change Canada Research Scientist. I'd like to begin by acknowledging I'm coming to you this afternoon from unceded Algonquin territory. A few points before we begin. This event will begin with a briefing from Armel and Nathan with regards to the summer season weather outlook. The briefing will occur first in English and be followed by the French briefing. After that, we will move to a question and answer period. The briefing is for attribution and can be recorded. To be called upon, reporters should change their screen name to include their full name and media outlet. In the interest of time, please keep to one question. Time permitting, we'll do a second round of questions. Bonjour, je m'appelle Samantha Bayard, je serai la médiatrice de la conférence de presse aujourd'hui avec Armel Castellan, météorologue de sensibilisation aux alertes à ECCC, et Nathan Gillett, rechercheur scientifique à ECCC. J'aimerais tout d'abord souligner que je me situe aujourd'hui sur le territoire algonquin non cédé. Avant de commencer, j'aimerais soulever quelques points. Pour commencer, Armel et Nathan feront leur présentation sur ce que l'été nous réserve côté météo. La présentation sera d'abord en anglais puis en français. Ensuite, nous passerons à la période de questions. Il sera possible de citer les intervenants et le point de presse pourra être enregistré. Pour poser une question, nous vous demandons de changer votre pseudonyme pour inscrire votre nom complet et les médias que vous représentez. Enfin, veuillez vous limiter à une question seulement. Si le temps le permet, nous ferons une deuxième ronde de questions. With that, I'd now like to introduce Armel Castellan and Nathan Gillett. C'est maintenant le moment de vous présenter Armel Castellan et Nathan Gillett.
Bonjour. Hello, Canada. Good morning, good afternoon. My name is Armel Castellan. I'm a warning preparedness meteorologist with Environment and Climate Change Canada. I want to start this briefing in a good way. Both Nathan and I are speaking to you from the unceded traditional territories of the Lekwungen and Wasanic peoples. Next slide, please. What I'm showing you here is an example of what happened in the month of May. You can see some very strong red coloring, signifying the anomaly of the temperatures that were seen across Western Canada, particularly over the territories, Northwest Territories and Nunavut, and Northeastern British Columbia and the prairies. Now, it's important to understand where we have been before we understand where we're going. So actually, this story starts back in fall of 2022, when, of course, we had also very warm conditions in September, October, and very dry conditions then as well. And now we've gone through the spring, which was actually quite cool in April and March and April, and became extremely warm in the month of May, as you can see with this diagram on the screen. Next slide, please. Now, looking at the precipitation signal, this is also an anomalous chart showing the blue with above amounts of precipitation in millimeters, and in red, orange, and yellow, below amounts of precipitation, again in millimeters. As you can see across Canada, from coast to coast to coast, with the exception of northwestern BC, Yukon, as well as parts of Ontario, most of the country is shaded in yellow or deeper orange, in particular Nova Scotia, eastern Quebec, right through the prairies, including northwestern Ontario and a big part of British Columbia. And this is true not just for 1 month, but for March, April, and May. So a very long period of time to have little in the way of precipitation. And again, this is also true when we look back several seasons, including the fall of 2022 in particular. Next slide, please. Now what I'm showing is the forecast, and what we're looking at here are probabilities of the temperatures being in a different category. The blues are below normal or below seasonal. The gray and purples, which there's very few of, are for near normal. And of course, the yellow, orange, and reds are for above seasonal temperatures. So the probabilities, as you can see, for mid-June to mid-July are extremely high over Quebec and Ontario, Manitoba, and even edging all the way over to the West Coast, with the exception of maybe parts of Vancouver Island. The only areas in the entire country that are forecast to have below seasonal temperatures over the coming months are for up in the north near Baffin Island, Ellesmere, as well as the Avalon Peninsula. Next slide, please. What we're seeing here are the same type of probabilities, however, they are for the entirety of July, August, and September. They look very similar in that Ontario, Quebec, the Northern Prairies, Northern BC, and up into the territories show some very high probabilities of seeing temperatures that are, again, in that above seasonal or above normal category. And so these were produced on the 15th, just 5 days ago, and are actually agreed upon by many international models that show a similar seasonal forecast, both the Americans, the Europeans, and any number of other meteorological agencies across the planet. Next slide, please. So before I leave you with the tools, I would like to say that the seasonal outlook provides an opportunity to identify potential risks and therefore better prepare and respond to extreme weather events. Canadians have experienced a hot and dry spring. Current seasonal forecasts suggest the anomalously hot conditions will continue across the country this summer. Potential consequences of this seasonal forecast include high frequency of wildfires that may exceed local management capacity, evacuations due to fire and poor air quality from smoke, potential for heat waves that create health risks and contribute to mortality for vulnerable communities, as well as the potential for continued drought conditions. So please stay weather aware and follow us on our various channels, including the Weather Can app on our online presence at canada.ca/weather, of course, on social media, on Twitter with ECCC weather, and then the two-letter number or letters for the province or the territory. We have, of course, Hello Weather and Weather Radio. So with that, I will leave you with Dr. Nathan Gillett with the Science and Technology branch. Nathan.
Thank you, Armel. Next slide, please. So I'm going to talk to you about how climate change affects extreme weather events in Canada. For one example of this, we can think back to the June 2021 heat wave, where a new record temperature was observed for Canada of almost 50 degrees Celsius. We've carried out event attribution studies on that heat wave, and we find that that event would have been almost impossible without the effects of human-induced climate change. So climate change is already having effects on extreme events in Canada. This graph shows the cost of natural disasters in Canada over the last 40 years, and climate change is one of the factors that's contributing to an increase in those costs. You can see, for example, the costliest event in the record is 2016, corresponding to the Fort McMurray wildfires, which the fire weather associated with those has been found to be made much more likely by human-induced climate change. So changes in extremes cause growing economic losses, social disruption, environmental damage, and loss of life in Canada. Next slide, please. How do we go about linking extreme events with climate change? Well, we can do this with an approach called event attribution. And the idea here is that we can establish a distribution of an event of interest in the current climate with the effects of human-induced climate change. And that's represented schematically here by the red curve. This would come from climate model simulations. And then we can compare that with the same distribution without the effects of human-induced climate change, and that's shown by the blue curve. And then for an event of interest, shown by the black line here, we can calculate the probability of an event at least that strong in the current climate, and we can compare that with the probability in a climate without human influence, and that allows us to quantify the effects of human-induced climate change on a particular extreme event or class of extreme events. Next slide, please. For an example of that, this slide shows the results of an attribution of area burn in BC forest fires. The graph on the left shows the area burned in southern BC in green. You can see that there has been an increasing trend in area burned in this region over the period of record. You can also see that this variations in the area burned are well explained by variations in July temperature, shown here by the purple curve. And climate change is one of the factors driving changes in area burn, and it's an important factor. And so based on this relationship, we can infer how much climate change has affected the area burnt in BC. And this study concluded that human-induced climate change has increased the area burnt in southern BC by a factor of between 7 and 11. So a big influence there of climate change on wildfire in BC. Next slide, please. But we can use climate models not only for attribution, but we can also use them to help us make projections of how extremes will change in the future in Canada. The example on the left is taken from the last IPCC assessment report from a chapter actually led by one of our scientists in Environment and Climate Change Canada. So this shows how a 1 in 50-year heat wave in the pre-industrial climate, or in the late 19th century, how the frequency of that event has changed over time. And this is a global average. But in the present climate, with a little more than 1 degree global warming, this kind of 1 in 50-year heat wave is now about 5 times more likely to occur. With a 1.5 degree C level of warming, this will be expected to occur around 9 times as frequently as in the pre-industrial climate, and at 2 degrees Celsius global warming, substantially more frequent, about 14 times more frequent than in the pre-industrial climate. So climate change is already affecting Canada. It's already affecting extremes around the globe. That there's a certain amount of further change that's inevitable, even if we are successful in reducing emissions to net zero by the middle or latter half of this century. But if we're not successful in an unmitigated climate where emissions continue to increase, we could expect about 4 degrees warming by the end of the century. And in that scenario, we would see that 1 in 50-year heat wave become something that we would see almost every year by the end of the century. So still a big difference between a climate where we're able to mitigate, where we're able to get emissions to net zero, and a climate in which the emissions continue to increase. And finally, this information on changes in extremes from climate models is also very useful for informing adaptation, for helping us make better decisions to adapt to climate change. As one example of this, our department has used information on changes in extremes to inform future building codes in Canada, as shown by this report here. So that concludes my part of the presentation. Thanks for your attention.
Bonjour, c'est Armel Castellan, météorologue de sensibilisation aux alertes. Je suis là avec vous pour discuter un brefage des prévisions saisonnières spéciales pour l'été 2023. Donc, prévoir et réagir aux phénomènes météorologiques extrêmes provoqués par les changements climatiques. Je voulais aussi commencer ce brefage technique pour vous dire que Nathan et moi vous parlent du territoire traditionnel du peuple Lekwungen et Wassanek. Prochaine diapo. Ce que je vous montre ici, c'est à quel point le printemps était chaud, en particulier le mois de mai. Par contre, il faut penser en fait à l'automne dernier, en 2022. Nous avons eu un automne très très chaud et très très sec, ce qui a vraiment mis les conditions en place pour ce qu'on a commencé à revoir ce printemps. Donc là, ce qu'on voit, c'est l'anomalie des températures qui est en rouge très vif pour le territoire du nord-ouest, le Nunavut et les prairies nord. On peut également voir que l'ensemble du pays, surtout l'ouest, a eu une anomalie de température excessivement forte, au point où c'était plus de 7 degrés au-dessus des normes saisonnières pour certaines régions ciblées dans le nord. Prochaine diapo, on va parler des précipitations. Donc, ce que vous pouvez voir encore une fois, c'est une anomalie à l'échelle de la saison mars, avril, mai, donc le printemps météorologique, où on voit un surplus de précipitations en bleu pâle dans le Yukon, dans le nord-ouest de la Colombie-Britannique et un peu aussi en Ontario. Par contre, ce qu'on peut voir en rouge, en orange et jaune sont le manque de précipitations normales dans la majeure partie du Canada, qui bien sûr a alimenté la saison des feux qui se propage de la côte ouest à travers toutes les prairies, les deux territoires orientaux et bien sûr les maritimes et l'est québécois. Prochaine diapo. Maintenant, on bascule à la prévision. Donc là, je vous montre pour commencer la prévision mensuelle pour la mi-juin à la mi-juillet 2023, et ce qui indique clairement des probabilités, donc en rouge, en orange, de conditions au-dessus des normes normales saisonnières. Donc, c'est sûr que les probabilités sont hautes pour le Québec, l'Ontario, le Manitoba, mais englobe aussi le reste des territoires, le nord de la Colombie-Britannique et la Saskatchewan, le nord de l'Alberta également. Donc, un signal très, très fort pour les 4 semaines et demie à suivre. Prochaine diapo, on va basculer maintenant à la saison complète. Donc, on regarde maintenant le mois de juillet, août et septembre. Donc, encore une fois, les probabilités sont très, très fortes pour le nord, pour le centre canadien, donc du Manitoba au maritime, mais incluant aussi le nord des prairies et la plupart de la Colombie-Britannique. Donc, une fois de plus, les probabilités au-dessus des normes saisonnières à l'échelle d'une saison au complet. La prochaine diapo. Alors, les prévisions saisonnières permettent d'identifier les risques potentiels et donc de mieux se préparer et réagir aux événements météorologiques extrêmes. Les Canadiens ont connu un printemps chaud et sec. Les prévisions saisonnières actuelles suggèrent que les conditions anormalement chaudes se poursuivront dans tout le pays cet été. Les conséquences potentielles de ces prévisions saisonnières sont les suivantes. Une fréquence élevée d'incendies de forêt pouvant dépasser la capacité de la gestion locale, des évacuations dues aux incendies et à la mauvaise qualité de l'air due à la fumée, la possibilité de vagues de chaleur qui créent des risques pour la santé et contribuent à la mortalité des communautés vulnérables, ainsi que la possibilité de conditions de sécheresse continue. Alors, avec ça, restez attentifs à la météo et obtenez vos renseignements météo avec l'application MétéoCan à notre site web canada.ca/météo, ainsi sur les réseaux sociaux. On peut nous trouver sur Twitter en particulier. Et bien sûr, Bonjour Météo et Radio Météo également. Alors, avec ceci, je vous passe avec direction de sciences et technologies avec Dr. Nathan Gillett.
Merci beaucoup, Armel. Prochaine diapo, s'il vous plaît. Alors, je vais parler un peu concernant les influences des changements climatiques sur les extrêmes au Canada. Et on a vu cette influence pendant en 2021, on a vu une vague de chaleur très extrême en Colombie-Britannique. On a observé un niveau record de presque 50 degrés Celsius. Et on a fait des études d'attribution concernant cet événement. On a trouvé que cet événement serait presque impossible sans l'influence humaine sur le climat. Alors, et ce graphique montre les coûts des catastrophes naturelles au Canada pendant les dernières 40 années. Alors, et les changements climatiques sont une influence importante sur les catastrophes naturelles au Canada. On peut voir que les coûts ont augmenté et on peut voir aussi que l'événement le plus coûteux pendant les dernières 40 années était en 2016 et c'était les feux de forêt à Fort McMurray. Et alors, en général, les extrêmes changent et ces changements entraînent des pertes économiques croissantes, des perturbations sociales, des dommages environnementaux et des pertes de vie. Prochain diapo, s'il vous plaît. Alors, et comment est-ce qu'on peut lier les changements climatiques et les phénomènes météorologiques extrêmes? Alors, c'est en utilisant une approche qui s'appelle l'attribution des événements. Et l'idée, c'est qu'on peut estimer la distribution d'un événement, d'un phénomène avec l'influence humaine en utilisant les modèles climatiques. Et on peut comparer cette distribution avec la distribution sans influence humaine aussi en utilisant les modèles climatiques. Et puis, on peut comparer les probabilités d'un événement dans le climat actuel avec la probabilité dans le climat sans influence humaine. Prochain diapo, s'il vous plaît. Pour un exemple d'une étude d'attribution, ce diapo décrit une attribution de la superficie brûlée lors des incendies de forêt en Colombie-Britannique. Et la graphique à gauche montre la superficie brûlée dans le sud de la Colombie-Britannique en verte. Alors, la ligne verte indique la superficie brûlée. On peut voir que la superficie brûlée a augmenté pendant les dernières 60 années. Et on peut voir aussi que les variations de la superficie brûlée sont bien expliquées par la température en juillet. C'est indiqué par la ligne mauve. Et on peut utiliser cette relation entre la superficie brûlée et la température pour faire une attribution pour estimer l'influence des changements climatiques sur la superficie brûlée. Et cette étude a conclu que les changements climatiques attribuables à l'humain ont multiplié la superficie brûlée dans le sud de la Colombie-Britannique par un facteur de 7 à 11. Alors, cette étude a conclu qu'il y avait une influence très importante des changements climatiques sur les feux de forêt en Colombie-Britannique. Prochain diapo, s'il vous plaît. Alors, on peut utiliser les modèles climatiques pas seulement pour l'attribution, mais aussi pour faire des projections des extrêmes au Canada. Et à gauche, on peut voir un exemple qui vient du dernier rapport du GIEC. Et ça montre comment un événement cinquantennal dans le climat pré-industriel, comment ça a changé et comment ça va changer à l'avenir. Alors, ça concerne un événement qui a eu lieu une fois en 50 années dans le 19e siècle. Et maintenant, cet événement, et c'est une moyenne globale, cet événement est déjà 5 fois plus probable que dans le climat pré-industriel. Et avec un réchauffement de 1,5 degré, ça devient 9 fois plus probable, plus fréquent que dans le climat pré-industriel. Et avec un réchauffement de 2 degrés Celsius, ça devient 14 fois plus probable que dans le climat pré-industriel. Alors, les extrêmes ont déjà changé et même si on réduit les émissions, on prévoit encore une intensification, encore une augmentation de la probabilité des extrêmes. Mais si on ne réduit pas les émissions, alors dans un scénario avec pas de mitigation, on prévoit presque 4 degrés Celsius de réchauffement à la fin du siècle. Et avec ce niveau de réchauffement, cet extrême devient, cette vague de chaleur se se produirait presque toutes les années. Alors, il y a une grande différence entre un scénario où on peut réduire, où on réduit les émissions jusqu'à zéro, avec un scénario où on ne réduit pas les émissions. Et dernièrement, on peut aussi utiliser les projections des extrêmes pour mieux planifier l'adaptation au Canada. Dans cet exemple, notre département a fourni les données et l'information concernant les changements des extrêmes pour améliorer les codes de conception futurs pour les bâtiments et les ponts. Et ça conclut ma présentation. Merci pour votre attention.
Thank you, Armel and Nathan. Merci, Armel and Nathan. To pose your question via Zoom, please use the hand raising function, or by phone, press *9 and *6 to unmute yourself. Sur Zoom, veuillez utiliser la fonction lever la main. Si vous avez une question sur votre téléphone, veuillez appuyer le étoile 9 suivi par étoile 6 pour établir le son. Okay, our first question is from Randy Thomas, 93.1.
Hi, thanks for taking my questions. Here in Fort Frances, we sit on the border with International Falls. As you may be aware, last year we had extreme flooding. At the beginning of this year, weather officials on both sides of the border expressed concern about more flooding this year. That all changed, and now we have drought conditions. So I know it's difficult to do long-range forecasting, but how does the public not become complacent by hearing things like, we're going to have a flood, now we're not going to have a flood, now we're going to have hot weather, now we're not going to have hot weather? So how do you get that across to the public that these things are more serious than what they want to believe?
Hi, Randy. Great question, and I can at least partially answer part of it. And one of the things that we did in this briefing is not show you the precipitation forecast. And the reason for that is that at a seasonal scale, even beyond about 2-3 weeks, it's extremely difficult to have any skill at forecasting how much or how little precipitation is going to fall. So, you know, when we talk about temperature, it's more the bread and butter of meteorological forecasting, at least in the short and longer term, including seasonal forecasts and beyond. When it comes to precipitation, it's really something that we see on the horizon of the modeling in the matter of, you know, like I said, 10 days, 2 weeks. And therefore, it's really important to focus on that part of the forecast on an ongoing basis in order to be ready for things like big rainfalls, snow, freezing rain, all of the things that might fall out of the sky that way.
Okay, wonderful. If there's nothing else to add, we'll go to Sarah Zari, Radio-Canada, pour la prochaine question.
Oui, est-ce que vous pouvez m'entendre? Parfait. Ben, ma question, en fait, je ne sais pas si vous allez pouvoir tenter d'y répondre, mais est-ce que, bon, c'est sûr qu'on prévoit des températures plus hautes que les normales saisonnières, mais ça pourrait dire quoi, là, par exemple, pour l'Est, le Québec, Ontario, Maritime? On pourrait voir des températures autour de combien? Puis est-ce qu'on peut s'attendre à des records? Est-ce que ça serait du jamais vu?
Alors, c'est une très bonne question aussi. Il faut aussi comprendre que même avec la prévision mensuelle ou à l'échelle d'une saison au complet, on ne peut pas vous dire sur un point du pays ou un autre qu'il va y avoir une canicule au début du mois d'août ou certaines dates au mois de juillet. C'est impossible à voir pour l'instant. Donc, il va falloir oui, savoir que la probabilité augmente d'avoir des journées chaudes à travers la saison, donc 30 degrés et plus, les probabilités sont plus fortes. Par contre, pour voir une vague de chaleur sur votre territoire à un moment donné, il faut regarder le court terme, comme ce qu'on va voir justement en Ontario dans les prochains jours et éventuellement sur le territoire de la province du Québec. Par contre, il va falloir encore une fois suivre la prévision de jour en jour pour voir à quel point on peut faire une prévision pour une vague de chaleur dans l'horizon plus proche.
Okay, the next question will go to Mia Rapson.
Hi there. Yeah, Mia Rabson from the Canadian Press. Just wondering if you could explain a little bit further the modeling on how climate change affects temperature, and specifically if we can know sort of how it's affected the temperature this year, or if it's too soon to tell.
Yeah, thanks very much for the question. So I would say that understanding of climate change effects on temperature is the most robust of all the kinds of extreme. We know that the climate is warming globally. It's warming in Canada. We've observed an increase in hot extremes. The models project an increase in hot extremes. So we know that climate change is increasing the risk of hot extremes in Canada. As I described in the presentation, we can also look at events in individual locations or classes of events, and we've done these kinds of studies, around the world. We've done these kinds of studies in Canada, and we know that climate change is increasing the risk of heat waves in Canada. In terms of events this year, well, I can certainly tell you in general terms, climate change has increased the risk of heat waves. It is increasing the risk of heat waves for this season ahead for future years. Beyond that, I can't give you kind of quantitative results for this summer, but we know that climate change is increasing the risk of heat waves. Thanks.
Thank you. And just sort of following up on that, I'm wondering if you could explain exactly what a heat wave would be and if we've had any so far, if what we've had so far this year would have been calculated or qualified as a heat wave.
Okay, thanks. I can add a little bit more. So we have actually, I described the science of attribution. We have started looking at events in BC and Alberta in the beginning of the season. Armel described how May was a lot hotter than average, and we have looked at the evolution of temperatures in Alberta and BC. Yes, there were heat waves in BC and Alberta in May based on the standard definitions of these things. And yes, we're working on this, but yes, we expect that, preliminary results indicate that human-induced climate change increased the risk of these heat waves.
I might also add, there's a couple different ways to think about heat waves. Of course, there's extreme anomalous events like we saw in June of 2021, again in May, and what the Mexicans and the Texans are experiencing currently. There's also the definition that relates to health. So we have criteria for 2 days, 1 night worth of heat. Those criteria are publicly available on our website, and you can see that if we reach that threshold of both daytime highs and overnight lows, then we will issue heat warnings in different forecast regions of the country. And already this summer, even this late spring, we have seen heat warnings be issued right across, and currently there's many over on the Ontario province. So that's another way to think about heat waves. They have a very clear set definition, and of course they have the implications of being dangerous for human health, particularly for the vulnerable. So again, a great moment to think about those who are not not hearing that the forecast is out there that could be dangerous, and going out there, speaking to those who are vulnerable, the elderly, the young, the pregnant women, people with pre-conditioned medical conditions are obviously going to be most susceptible to heat.
Okay, thank you, Nathan and Armel. On va continuer à la prochaine question. Nous provient de Daniel Birou, La Presse.
Oui, bonjour, vous m'entendez bien? Bonjour. Oui, donc Daniel Biru de la presse. Je ne sais pas si vous seriez en mesure de répondre à cette question-là. On a vu dans les derniers jours qu'il y avait en fait la saison des ouragans qui commence un peu plus tôt en 2023, là, qui a pris naissance dans l'Atlantique, qui est supposé toucher les Caraïbes et le sud des États-Unis au cours des prochains jours. Est-ce que vous pensez qu'on pourrait s'attendre à avoir des répercussions des ouragans en fait, en début d'été dans certaines parties du Canada?
Alors, merci Daniel pour la question. Je peux vous donner une petite réponse et je peux passer ça à Nathan également. Et effectivement, la saison est très précoce. Il y a des associations avec la saison des ouragans qui est reliée avec l'Atlantique Nord, donc il y a beaucoup de chaleur anomale dans l'océan là-haut aussi. Et donc, cela peut avoir une répercussion sur l'évolution de la saison. Et puis, normalement, c'est ce qu'on est en train de voir pour l'instant. Après, les ouragans, on les prévoit et ils peuvent avoir une direction qui peut englober une partie du territoire canadien, notamment le sud et l'est de l'Ontario, ainsi que le Québec et les Maritimes. Alors, les prévisions seront à voir pour les détails vis-à-vis le territoire canadien.
Merci, Armel. J'ai rien à ajouter, oui.
Okay, we will continue to the next question from Sija Liu, CTV News Windsor. Apologies if I mispronounced your name.
No worries. Thank you so much, Armel and Nathan, for being here. So I'm located here in southwestern Ontario, and that was part of the graph that showed we are going to have above seasonal temperatures. Can you talk about the impact of El Nino and the potential of cooler conditions?
Yes, absolutely. Great question. And there's a lot of media interest in El Nino, La Nina. We're just finishing, or we finished our 3 La Nina winters in a row. Now we've shifted completely at the equatorial Pacific into El Nino conditions, meaning sea surface temperature anomalies are above normal, if you will. And the important thing to note there is that we have, internationally fairly robust modeling showing that El Nino will continue through the summer, into the fall, and likely into winter. Now, how strong it will be remains to be seen, but it looks to be a fairly strong phenomena this time around. The other piece that's very important for Canadians is that statistically, El Nino doesn't impact our weather until we get to around Christmas time, hence the name. And will likely at that point have an influence on the Canadian landmass, usually milder and drier for parts of the country and wetter for other parts further into the east. And those typically happen between December and about middle of spring. So right now, we won't have a big influence from El Nino. We have all of the other influences, including climate change and the seasonal projection that really does show these higher probabilities of above seasonal temperatures.
Thank you so much for that explanation. And if possible, for a follow-up, you had mentioned the difficulties of predicting precipitation. Is there anything you can say in terms of, are we going to have a wetter or drier summer in Southern Ontario, or is that out of the picture right now?
Well, from a seasonal projection, you can look at the output. It is available. What you will also see when you match it up with the seasonal or the skill, the atmospheric science skill of that type of projection, is that it's excessively low, and therefore often the signal is not available. There will be some patches here and there across the country, but generally speaking, there is no signal to really hang your hat on and say, it's going to be this way or another. It's really going to come down to looking at the forecast at a shorter time period, usually under 10 days, sometimes even 2 or 3 days, when it's very convective and you're dealing with mesoscale or smaller scale events, severe summer weather, really those type of scenarios need to be looked at a shorter time period.
Okay, great. Please use the hand raising function if you have a question. Veuillez utiliser la fonction lever la main si vous avez une question. And there we are. The next question is Eric Stover. Oh, I saw Eric's hand and then it went down. Eric, go ahead.
Hey there, can you hear me? Okay, great. So we're seeing in Alberta right now that they've had some wildfires and now they're seeing flooding coming pretty quickly afterwards. So I'm just kind of wondering if you have anything to speak to that, this fluctuation of weather happening really quickly. Is that climate change related? Can these different weather phenomenon kind of work together to create an even worse effect? Just wondering if you can speak on that.
Perhaps I'll go ahead and then hand over to Armel. So in general terms, climate change increases the risk of heat waves. That's a very clear signal. But it is also decreasing the risk of cold temperatures, and cold extremes have warmed over Canada over past decades. Another effect of climate change is to increase the intensity of the most intense rainfall. So yes, the likelihood of hot extremes has been increased by human-induced climate change. Like I said, climate change does increase the intensity of the most intense rainfall, but there's a lot more variability in rainfall. That is a less clear signal. But it isn't necessarily changing the variability of climate. In fact, if anything, variability in temperatures over North America is decreasing, not increasing. So yes, there are effects of climate change on these different types of extremes, but it's not, in general, increasing variability. Thanks.
Yeah, and if I could add on that, you know, what we're seeing increasingly in, you know, the Canadian landscape, let alone across the world, are events that are not independent of other events. So, you know, June of 2021, the heat, the fires that were started very early that season, followed by a very strong atmospheric river in November after a very wet fall up until that point, showed at which point the landscape and the environment is susceptible to the impacts of the first type of signal or event, the dry, the hot, the smoky, and followed by a very wet event. And similarly, what we're seeing in parts of Alberta with upwards of 160, 180 millimeters over the past 48 hours are a lot of rain over an area that has been very dry, very droughty, and some of it with burn scars. And so those things are what we call cascading impacts, and can not be ignored because they're quite literally tied together. So that's just another way to understand that, you know, nothing is independent. The ecology is not rocket science. In fact, it's much more complicated.
Okay, please use the hand raising function if you have a question. Veuillez utiliser la fonction lever la main si vous avez une question. There are no further questions. This concludes today's event. Comme il n'y a plus de questions, ceci conclut l'événement d'aujourd'hui. Merci.